All right, hello everyone. So today we have a calculus 2 problem, or problems, I should say. We'll be using the ratio test to figure out the convergence of two series. Today we're going to work on series A, which is a series sigma 1 to infinity, quantity 2n factorial divided by quantity n factorial all squared. Okay, so I'm going to be using the ratio test, and let me just see what the ratio test says, which is given a series going from 1 to infinity, a sub n not equal to 0 for infinitely many n. Consider the limit L equaling to limit as n goes to infinity of absolute value of the quantity an plus 1 divided by an. If your limit is less than 1, then your series converges, n equals 1 to infinity, an converges. If L is greater than 1, then the series 1 to infinity, an diverges. If L equals 1, then the test is inconclusive about whether the series converges or diverges, which is kind of like the worst case scenario, because a lot of the time you'll figure out a limit and you did a bunch of work and it just didn't, it gives you 1 and it doesn't tell you anything. Now, you might have gone over a bunch of tests now, like the integral test, the limit comparison test, etc. And you might be at the point where you're asking, so if you have all these tests, when should I use, which test? So let me go over why we're using the ratio test, besides just the title of the video here on this series. I have factorials. Ratio test works pretty well with series with whose sequence has a factorial in it or an exponent. So that's why I'm picking the ratio test. It works out pretty nicely. So that's why we'll be using that here. And the other thing that I wanted to mention was this note, n plus 1 factorial equals n plus 1 times n factorial. That's a very, very useful rule when you're working with series and the ratio test, because you're going to simplify. You need to simplify, really. And just to give you an idea of how this rule works with numbers, let's say 8 factorial is like saying 8, 7, 6, 5, 4, 3, 2, 1. But 7, 6, 5, 4, 3, 2, 1 is like 7 factorial. So that's what this rule is saying, that if you take the factorial of a number, it's equal to that number times the factorial of one number less than it, okay? So we'll be using that. All right, so let's go ahead and begin. The first thing you take the limit as n goes to infinity of absolute value of an plus 1 over an. Then you have the limit as n goes to infinity of, I replaced all the n's with n plus 1. So again, let's going back to that series. You get 2 times quantity n plus 1 factorial divided by n plus 1 factorial all squared divided by 2n factorial over n factorial squared. So what I'm going to do next is first take the absolute value off. I don't need it anymore. And I'm going to flip the fraction 2n factorial over n factorial squared and turn this into a multiplication. So we have what we call a complex fraction. Okay. And 2 times quantity n plus 1, I can distribute this 2. And this would be 2n plus 2 factorial. And what I'm going to be doing now is using that fact that I wrote earlier, that n plus 1 factorial is n plus 1 times n factorial. Okay, so let's apply that to, first of all, the numerator. 2n plus 2 factorial is like saying 2n plus 2 times 2n plus 1 factorial. Okay, yeah, and that expression works for pretty much anything with a factorial. It doesn't have to say n plus 1. Just as long as you have something factorial, you can always write it as that something times 1 less than that factorial. n plus 1 factorial squared, that's like saying n plus 1 times n factorial all squared. Okay, and yeah, and furthermore, this n plus 1 n factorial squared you can rewrite that by properties of exponents as n plus 1 squared n factorial squared, like that. And voila, canceling things out. And one more thing that I can do to cancel out, so let me write what I have so far, which is 2n plus 2, 2n plus 1 factorial, all over n plus 1 squared, 2n factorials after we canceled. That 2n plus 1 factorial, we can rewrite that as 2n plus 1 times 2n factorial. And I go all the way just to do that, just to cancel. And there's one more thing you could do with factoring a 2 out of the expression 2n plus 2, but I think that's enough with the algebra. So if we take this limit, and I'll let you work on that, that gives you 4, which is greater than 1. And therefore, according to the ratio test, if L is greater than 1, then the series diverges. So our series n equals 1 to n factorial over n factorial squared will diverge. Okay. All right. So again, we use the ratio test because of the fact that we had factorials. For the next video, I'll work on part B, which is series 1 to infinity e to the n plus 4 over 1, 3 times 5, da da da. So basically, it's like the product of the odd numbers here. It's like an odd factorial, think of it that way. And yeah, we'll work on that. And thanks for watching.